Okay, so then this is the homework from the 4th of October. It was two bits of paper questions I gave you to do. So a loudspeaker has three main components as shown in the diagram: the magnet, the coil, and the cone. The cone vibrations cause pressure variations in the air that produce sound waves of frequency 512 Hertz. So the first question, part 5, is what type of wave is sound? So it's longitudinal, or you could say it's mechanical. They're the two classifications of a sound wave. Either would be correct. Calculate the wavelength of the sound produced. So that's going to be C equals F lambda. C is down the bottom here, 340. F is the 512. Lambda. Isolate the lambda by dividing by 512 to cancel. Divide by 512 to balance. 0.66. The amplitude of the vibrations of the cone determines the amplitude of the sound wave produced. What musical characteristic is determined by the amplitude? So amplitude, the characteristic connected with amplitude is loudness. That's all you have to say there. Calculate the sound intensity for a person's... a loudspeaker has a power of 80 milliwatts. Milli is 10 to the minus 3. Calculate the sound intensity for a person standing 7 meters from the loudspeaker. So intensity is power over area. The power is 80 by 10 to the minus 3. The area, I said, is the area of the surface area of a sphere. So it's 4 pi r squared. So it's 80 by 10 to the minus 3 over 4 pi 7 squared. And that is 1.3 by 10 to the minus 4. So you remember we did these numbers are always really awkward, the watts per meter squared numbers. The sound intensity is halved when they stand a distance d from the loudspeaker. Calculate d. Okay. So the sound intensity is halved okay. And so that means I take this 1.3 number and divide it by 2. So the sound intensity is now 6.5 by 10 to the minus 5. The power being emitted hasn't changed. And it's 4 pi, and I don't know, we call it d, the radius of the sphere. I don't know what that is. If I multiply by d squared to get that off the bottom, and then multiply by d squared over here, and then if I divide by 6.5 by 10 to the minus 5 to get rid of that, and do the same divided over here. So it gives me d squared on the left, and on the right it gives me 80 by 10 to the minus 3 over 4 pi times 6.5 by 10 to the minus 5. Okay. Equals that divided by... what am I after doing? Okay, so I got 98. So d squared equals 98. And then if you square root both sides, I get 9.9 meters is the distance. I have the answers here, so that is right. After this, the speaker of power 18 milliwatts is replaced by a speaker of power 20 milliwatts. Calculate the decrease in sound intensity level. Sound intensity level is decibels. Okay, so, right. I suppose it doesn't really matter which one I use. Okay, so we don't know the sound intensity. The power has gone to 20 by 10 to the minus 3. And then it's 4 pi 9.9 squared. Okay. So that's giving me 1.6 by 10 to the minus 5. And it was 6.5. So it was 6.5 by 10 to the minus 5. And now it's gone to 1.6 by 10 to the minus 5. So if I divide them, I get 4. So it has decreased by a factor of 4. Now, when you half the sound intensity levels decrease by 3 decibels. So if you're decreasing something by a factor of 4, you're halving it and halving it again. So when you half it the first time, the sound intensity level goes down by 3 decibels. When you half it the second time, the sound intensity level goes down by another 3 decibels. So that means in total, the sound intensity level is going to decrease. It's going to decrease by 6 decibels. So that every time the sound intensity halves, that's in your, we made a note of that in the book. So if the sound intensity halves, the sound intensity level decreases by 3 decibels. That's what I'm using there. Yeah. Okay, that's that one. This one, the frequency F of a stretched string depends on its length, its tension, and its linear density, or we called it mass per unit length, mu. For each of the following pairs of variables, sketch a suitable graph to show the relationship. Okay, so you just have to know the relationship, or you can go in and get the formula tables book and kind of pull the relationships out of the formula if you don't know them off by heart. But frequency is proportional to the square root of tension. So if you just do this and go root T and F, and that will be a straight line. That's that one. B. Frequency and length. Frequency is proportional to 1 over length. So if you do 1 over length, frequency, that should be a straight line. And then C is frequency with mu. So frequency is proportional to 1 over the square root of mu. So if you do 1 over the square root of mu, frequency, that should be a straight line. So there are your relationships. For each of the following, state the, oh, I scrolled too far, hang on. State the effect on the frequency if the variable is increased by a factor of 4. Okay, so if tension is increased by 4, frequency, they're directly proportional, so it's also increased, but it's increased by the square root of 4, which implies that it's increased by 2. So frequency increases by factor of 2, which means it multiplies by 2. That's what that means. Okay, length. So if the tension increases by 4, the length, they're inversely proportional, so the length decreases by 4. Oh, not the length, sorry. Oh my God, hang on. Right, the second one is length. So we're talking about the length increasing by a factor of 4. So if the length increases by a factor of 4, length and frequency are inversely proportional, so frequency decreases by a factor of 4. So if length multiplies by 4, frequency divides by 4. So that's what this means, that frequency multiplies by 2, and this means that frequency divides by 4. Okay, and the last one is mu increases by 4. Okay, so they are inversely proportional, which means the frequency is going to decrease, but it's going to decrease by the square root of 4, which would imply that the frequency is going to decrease by square root of 4 is 2. So frequency decreases by a factor of 2, or in more plain language, frequency divides by 2. Sorry, I'm on the other solution, so just let me check that's right. Yes, it is. Okay, part 5. Oh, sorry, I didn't read the bit above it. I will now. A string is stretched between 2 fixed points, which are I converted that in my head. 62 centimeters, which is going to have to be 0.62 meters apart. The string vibrates with a number of different harmonics. The speed of sound in the string is 380 meters per second. What are harmonics? So harmonics are multiples of the fundamental frequency. So the fundamental frequency was 8 hertz. Then the second harmonic would be 16 hertz, and so on. Okay, part 6. Draw the diagram to show the string vibrating at its third harmonic. Oh, I don't know. Right, I'm just going to do them all. So this is the first. Oh. So 2 nodes. 1 antinode. Okay. I'm going to keep these same width and just add in my third node. That gives me kind of an indication of how to draw it. So that is 3 nodes, 2 antinodes. So then my third harmonic is going to be 1, keep those, equidistant, it'll do. And then we go and draw in between. So 4 nodes and 3 antinodes. And just because I've done them all, I don't want the examiner to be confused. This is the third harmonic. Yeah, looking at it now, obviously the third harmonic has 3 hoops in it, but I wouldn't remember that, so I would just go from the start. Right, cool. The last one then is calculate the frequency of the string when it is vibrating at the third harmonic. Okay. Right. So if I put in, maybe I'll do it in a different color this time. Put this in. Try that again. Okay, so the length here is 0.63 of a meter is what we were told. So the length is 0.63 meters. Now, we can also write the length in terms of lambda. So this here is a node to node, which means it's lambda over 2. This is another node to node, which means it's lambda over 2. And then this is another node to node, which means it's lambda over 2. So that's a half plus a half plus a half. So that's 1.5, 3 over 2, whichever. Okay, so if the length is 0.63 and the length is 3 over 2 lambda, then they're equal to each other. So 3 over 2 lambda equals 0.63. We want to isolate lambda, so we can divide by 3 over 2 to cancel and divide by 3 over 2 on this side. So then lambda equals 0.42. And then we use C equals F lambda. What was the speed? 380. So 380 equals the frequency we don't know by 0.42. We want this, so we will divide by 0.42 to cancel and divide by 0.42. Okay, so 380 divided by 0.42 is 904.76 hertz. Is the frequency. Sorry, now stop checking again. Let me just check them. And that is right. Sorry. I'm sure you noticed, but I used the wrong length. Oh, that's so annoying. So it's not 63, it's 62. It's not going to change by much, but I may as well have the right answer. So change all these to 62s, which will make this answer. I think it'll still be 0.4. 0.413 recurring, which is what goes over here. And that's 0.413 recurring. So we cancel them. So 380 divided by that is, okay, 919.35, which is right. It's an absolute classic example there of a slip. So I stupidly didn't go back up and recheck the number. I thought I knew it, so I wrote it down. It's a clear slip. I had it all really kind of clearly laid out that I was using the length to be 0.63, which means whatever that question was worth, I would have just got a -1 for my my slip. Anyway, so they're the solutions. So please make sure that you understand them. If there's anything you don't understand, just let me know. I'm back in tomorrow, so yeah, let me know.